Hello, everybody. Welcome. Thank you for joining us today. We're just going to wait a couple more moments just as to allow time for more people to come in. Hope you're all doing well today.
Morning.
Good morning, TJ. Doing well?
Very well, thank you. Yourself?
Yeah, always.
Hi, everyone else.
Morning.
Morning.
So I think we'll just crack on and we'll allow people to come in as they join. So, yep, Borada, good morning. Welcome, everybody, and thank you for joining us today. As I'm sure many of you are aware already, the Selkie project is organizing a series of events focused on providing business support for companies looking to diversify into the marine energy sector. So these events give your company the opportunity to learn more about key themes from experts in the sector and to help in your endeavors to enter and work in this innovative and growing industry. It will also give you the opportunity to network and meet with other companies that are new to or working in the sector. So today's session, we're going to be focused on manufacturing for the marine environment, and we're delighted to be joined by our expert today, John Bailey of Safinah Group. Safinah Group are experts in optimizing coatings to protect marine assets. They offer independent consulting and technical services to the whole spectrum of coating activities, covering the entire lifetime of an asset, from product specification, selection, application to maintenance, repair and failure investigation. So in this session, Safinah will talk about their experience in creating functional specifications to optimize performance, reduce maintenance, reduce costs, and prolong the lifetime of assets in harsh environments. So just a few housekeeping guidelines and an intro to the Selkie project before we begin. If I could ask that everybody please remain on mute unless you're speaking. This helps to prevent any feedback and ensures that we can hear the speaker clearly. It would be great if people could include their business name in their name on Zoom. So if you just right-click on your own logo, you add your business name. This just means we know where you're all joining from us today and help with any networking. So John will give his presentation shortly. If you have any questions during the session, please just put them in the chat, and we will come to these at the end of John's presentation. Also, if you need any assistance at any point, if you have any technical issues, please also just pop these in the chat, and we'll have a member of our team will come in and assist you there. So yeah, you can follow the Selkie project on LinkedIn and Twitter. We also have a website, selkie-project.eu, where you can keep up to date on all Selkie project activities, including the rest of these Meet the Expert sessions. An additional point I'd like to mention today: if you're a member of Marine Energy Wales or the Selkie Network, you'll be receiving an email about our Road to COP26 initiative launching later today at around noon. The Road to COP26 initiative aims to demonstrate the sector's capability and ambition to align with the goals of COP26. We would like to encourage your participation by using the hashtags #26 for COP26 and #WeSupportMarineEnergy. So this is on Twitter and LinkedIn. You can cite your participation in the Selkie Meet the Expert event as a demonstration of your involvement with international reach and relations, as well as contributions to the collaborative nature of the marine energy sector in Wales and Ireland. We want to get this trending, and we'll be using these hashtags around a lot of our activity that we are doing to build interest around our Road to COP26 initiative. So before I hand you over to John, I'm just going to do a very quick presentation on the Selkie project. I'm sure many of you, if you've been to these sessions before, will have seen this already, but this is just to give an overview of what the Selkie project is for those of you who are new or perhaps unfamiliar. Hang on, just going to change this around. So yeah, the Selkie project is a collaborative project across Wales and Ireland. We have 6 organisations that are participating: University College Cork, Swansea University, Marine Energy Wales, Mentor Morn, DP Energy, and Gavin and Doherty Geosolutions. So what is Selkie? Selkie is all about bringing together research and academia. We're developing open source tools for the benefit of industry, being made by some of our academic partners, and just making sure that that communication channel is open between research and academia, so that research is useful for industry, and industry are providing feedback in to help guide that research as well. Here we just have a little bit of an overview. We're creating these tools and models that are going to be open source, open access for the benefit of industry. We have some pilot projects with a wave and tidal device to help demonstrate these tools in practice. And we're also doing some industry engagement where we're trying to push forward some business support, training companies and providing them with access to materials to help them enter the sector. And that's part of what sessions like today are all about. And then we have our Selkie Network. This is just a sample, but loads of different companies have joined the Selkie Network. It's free to join. I'd advise going onto our websites. All the details are there, or contacting my colleague Sophie. I'm sure she can drop her contact details in the chat. So if you're not in the Selkie Network already, feel free to reach out. It's free, and you can get business support and guidance to help you join this innovative sector. So that's enough from me. I'm going to hand you over to our expert for today. That is John. So over to you, John.
Yeah, thanks very much for that introduction, Jay. And I'll just share my screen and you can confirm it's working, and then we'll get underway. So should be full screen.
Yep, that's working just fine.
Brilliant. Okay. So hello everybody, I'm John and I'm from Safinah Group, and today I'm just going to be talking about coatings for the marine environment. So I'm going to cover a few bits and pieces. A Safinah Group introduction, just to give you some background, although Jay did a pretty good job of that himself. Talk a little bit about the coatings, the general challenges, and then some case studies of things that we've worked on recently that I think will be of interest to the people on the presentation today. So Safinah Group, we were founded in 1998. We've got offices in the UK, Denmark, Singapore. We're made up of independent consultants, so we're not associated with any particular paint company, manufacturer, applicator. We're entirely independent, so the advice you get is independent. We've got over 400 years of collective experience. So between our consultants, we add up to 400 years of collective experience, which we think sets us apart from independent individual inspectors and consultants. We're made up of quite a variety of different people. So I'm a polymer and formulating chemist. I used to work for one of the big paint manufacturers, actually designing and developing the chemistry behind these paints. We've then got material scientists, naval architects, engineers, and also experienced coating superintendents and inspectors working around the world. One of our other advantages is that we have quite a wide focus in terms of the markets that we serve, and we can bring this to any particular the project that we are working on. So as we work in offshore renewables, but we also work in oil and gas. So on the left hand side, you've got a picture of a FPSO, floating production, storage and offloading vessel. Onshore, so bridges and other structures, very heavily involved in the marine and super yacht markets. And then also any land-based infrastructure, so chemical industries and anywhere else that's really using coatings to protect their structures. So we can bring this broad knowledge onto a particular project, and this cross-fertilization of ideas can help solve some of the more unique challenges that we come across. And we offer a 360-degree service. So we are coatings experts and we cover absolutely everything to do with coatings. So that can be helping people with market research, formulation, specification and contracts, all the way through to supervising the coating application. And if things go wrong, then we can start to help with the failure investigation, warranty work, and expert witness as well. So if actually things become legal, we can do a lot of work around, expert witness. So again, we can use this broad spectrum of experience for any particular project. So our knowledge of failure investigation and expert witness, we actually feed back into our specification and contracts work to try and prevent these mistakes happening again, which is something that a lot of people won't be able to do. And you'll find that quite a lot of companies aren't that happy to talk about failures because they'd rather they didn't happen. So they tend to brush them under the carpet and not actually publicize them. Whereas we're independent, quite happy to talk about the failures that we've been involved in and how these can stop or be prevented in the future. So coatings, I think this is probably fairly straightforward for most people, but the need for coatings it principally is to stop corrosion. So I've got some statistics that 1 ton of steel rusts every 0.2 seconds around the world. And in any given year, we spend roughly $2 trillion on corrosion. So it's a massive problem. And coatings are one of the ways that this can be tackled. But it's not just corrosion that we're trying to prevent when we actually use coatings. So there are other things that we can do with them. Some of the things that are probably of interest to the people on the call today, trying to prevent marine fouling, chemical resistance. So if you, again, this is particularly in industry, if you're working in the oil and gas, you often use them to prevent attack by particular chemicals that you can't achieve in other ways. Fire protection and insulation, which is a very specific area that I used to work in. But this is actually preventing structural steel in the event of a fire using coatings. And then obviously aesthetics, it's not just about stopping something from rusting, but you've also got to keep it looking good in certain environments. So I think that's quite an important one that people want to consider. Trying to move. So some of the general challenges that we come across, if you ever work in the paint industry, one of the things that you'll hear quite a lot is that paint fails because of poor surface preparation. And that is true. If your surface preparation is bad, if it's not blasted properly, if there's not a profile, if it's not clean, you will get coatings failure. However, looking back at some of the Safinah case studies that we've worked on over the years, we found that that's not always the main reason. So on the right-hand side at the top there, we've got a graph that shows the percentage of failures across some of the projects that we've worked on. One of the biggest, well, the biggest column is design, and then we've got specification, product selection, operation, so that's in-service conditions. Planning and scheduling is around the actual application, as is the process. Chemistry is the choice of coating that was actually used, and if the chemistry or the formulation itself was good, and then other. So it isn't always about surface preparation, and this is some of the message that we're trying to get across, and this is probably where we can help people, is actually getting involved in the design and the specification part, understanding what it is. So we like to produce a functional specification which is unique to a project and actually meets the need of that project. So it's not a generic specification that you've got from a paint company or from a technical data sheet. This is something we work through, understand the end needs of the client, and then actually produce a specification that meets those needs. So the next thing is it's cheaper to get it right first time. A very crude graph in the bottom right there shows the cost per square meter in an orangey red color, and then the ability to influence cost in the blue color. And at design phase, the cost per square meter to actually get it right is relatively low, and the ability to influence is high. So at this point, when you're actually designing your structure, working out what coatings you're going to be using, you've got a lot of ability to influence, and the cost per square meter is low, and that's really where you want to get things right. As you get through new build and into in-service conditions, your ability to influence cost is reduced dramatically. If you're trying to repair something that's offshore, you're very limited, and most of your costs aren't going to be in the actual raw materials and the cost of the paint itself. They're going to be in actual access and the people doing the work. If you're trying to prepare surfaces and paint while using rope access, it's incredibly expensive. And at that point as well, you're very limited in the coatings that you can use. Again, when you're painting offshore in a maintenance situation, you've got to have very specific products. You can't use the same products that you would use at new build because the environment itself is so tough. And again, that means that you're very limited as to what you can pick, and the costs are higher.
So I'm listening on coatings in marine environments here.
So three things that's important to understand. Design affects performance. You need to understand the application process that you're going to use, the installation process. So that's getting it from the build environment to actually in service, the in-service conditions themselves, and then the performance requirements there. And then quite importantly, I think I'll come to at the end, is how performance is validated. So design, to touch on briefly, because it's quite complicated, and you really need to understand the specific design that you're working with. But I've picked up some examples. The easiest thing to coat is a nice flat surface, but nice flat surfaces are never found on structures because they're not particularly useful. And what you actually end up with is things up on the top right there, which I think is a ballast tank from a ship. And that becomes much more complicated because you've got angles, you've got joints, you've got corners, and you've got welds. And interior spaces as well is also a challenge, so access is difficult. And it's these things that you need to be thinking about when you're actually looking at your coatings. Is not design a structure and then think, oh, right, now we're going to paint it. It's actually think right from the start, we're going to have to protect this structure from corrosion. How are we going to do that? And how should we design this so that it's easy to coat and it's going to give us less problems? So if you're not familiar with the painting process, the top right there actually shows the structure being stripe coated. So every single corner and weld of the structure needs to be brush applied to ensure that you get good coverage. And so that's really quite time consuming. So you can see there, and that'll be done on every single coat. So it adds an extra person, almost certainly extra hours, extra materials, and the chance for things to go wrong. And then the one in the bottom right is a very simple problem to fix, but if you don't get it right at the start, it's something that we see quite a lot. So I'm not sure how clear this is going to be. It might depend on how big your monitor is, but this particular beam has been stitch welded to a plate, and that's absolutely catastrophic from a coatings point of view, because what it leaves is a gap between the welds, which is going to be where corrosion is going to start. You're not going to be able to get your coating in there to actually protect it, and it gives you an environment that's going to be awful for corrosion. So a simple design tip there would just be to actually do continuous welds and don't have these gaps. And there are loads of things like this that need to be considered when you're actually designing your structure and getting it fabricated. So the next one is application, installation, and in-service. So there are different interests here depending on who's actually paying for the work and who's actually running the project. So the applicator has interest around cost, speed of cure, and overcoating intervals. So that's basically how quick they can get it through their workshop. If they've got a lot of work going, their prime interest is how quickly can they get it painted and get it out so they can get the next job in and continue to earn money. And they're also interested in general ease of application. So I've put a nice photo up on the right hand side there, and this is a hot twin feed spray setup. So it's designed for spraying two component paints that need to be kept warm, but are also very reactive, so they need to be kept separate for as long as possible. And that's a really complicated bit of kit, as you can see. It costs as much as an expensive car, and so applicators aren't particularly keen to use that. So if you ask to use a paint that has high performance but requires a piece of kit like that, you may find that the recommendation is to use something lower performance that uses simpler kit that they're more familiar with, and it's going to be less hassle for them. But it may not be the best use. It may not be the best product for the end user. And so if you're looking at putting something in service for 25 years, you might not be bothered that it takes an extra week to coat it, or it costs a little bit extra at that point, but because what you're really interested in is your 25 years of service. Whereas the applicator is interested in their 1 week of getting it coated and getting it out of the door. Installation. So on the bottom right there is actually quite a big project to illustrate an example. But when you're building something, you need to think about how you're going to coat it. So this is a hull of a ship, and it's a modular construction. So it's being built in sections and then lifted and installed as huge sections. So you've got a lot of things going on there. You've got a lot of chance for damage. So you're lifting a section with a crane, which is going to actually cause the structure to flex. And so you need to understand if the coatings are going to withstand that. And there's a decent chance when you start lifting things and moving things that are going to get damaged. There's going to get bumps and scrapes. So it doesn't need to be something that big. Even if you're lifting something off a boat to put it onto the ocean floor, or even just to float it, if you're strapping it, if you're using chains and cables, you're going to damage it. And so what is your QC and repair strategy? How are you going to actually understand that? And this needs to be done right at the start. So if you're going to damage your coating, how are you going to repair it in situ? What are you going to do? Are you going to put the same coating on that you used previously? Or if you damage it while you're lifting it into position, are you going to be able to do that when it's then floating somewhere in the sea? But you need to think about that in advance, as opposed to thinking about it when it actually happens, because it's inevitable. The next one that you consider is in service, and this is where the owner or the operator really has their main interest. So at this point, you need to understand what are the conditions that it's going to be in. Different marine environments have very different conditions. So if they're warmer, it can be harsher. If it's cold, again, different conditions, especially if it's going to be below freezing. If it's going to be fully immersed, partially immersed, so you need to think about these things. There is actually a decent standard that most people refer to at that point, which is ISO 12944. that helps you categorize the different environments, in terms of the corrosive nature. And that covers everything from onshore, fairly low corrosive environments through to immersed at sea. But do you fully understand that? And do you know what those environments mean? And do you know what the implications are? And it's not the only standard. So occasionally people do come up and use other ones depending on which industry they're working in. So I think I touched on this with damage. Next consideration will be new build compared to maintenance. The same coatings that we use at new build may not be suitable for repair. And as I said, repair, it's inevitable. Damage is going to happen. So again, on the right there, I've got a photo. It's the side of a ship, and that's fender damage, just where it's been, well, once it's left dry dock and they're actually fitting out while it's floating, it's been moored and it's been damaged, and so it needs to be repaired. So some of the things you consider when you look at maintenance compared to new build is that surface preparation isn't going to be as good. And this is primarily down to the environment. You're going to be potentially operating off temporary platforms, maybe rope access. You may be over water where you can't use a grip blasting because of the contamination. And so it's really likely that you're actually going to be using hand tools and hand preparation, which isn't going to give you the kind of the high quality surface preparation that you need to use the high quality coatings. So what you are going to need is something that's more surface tolerant. So maybe even tolerant to rust and tolerant to moisture. But these are different conditions from what you would have in the application, which is probably going to be a nice controlled environment. And so if you take the coatings that you used originally and try and reapply them in a maintenance environment, it probably won't work, and they certainly won't give you the lifetime that you expect. So you need to relook again at what you're specifying and what you're actually going to be using. Again, other things to consider is that you may not be spray applying, especially if it's small areas. You may be using brush or rollers. You may want faster drying because you'll have limited access. So if you're thinking about things like wind turbines, you're very much limited to the 12-hour shift or so that you can actually work, because you've got to get the boat out to the wind turbine, do the repair, and then get back. You can't have shifts rolling on and off doing 24 hours a day coating whenever it's convenient, because you're reliant on things like the weather and the tides. And because of that, you'll want fewer coats. Normally you'll find a 3-coat system specified for quite a lot of offshore, but a 1-coat is ideal because that's one visit, and it's the number of visits that creates challenges, so you don't have to keep going back. And you may even want simpler products. So rather than using something that's a 2-component that you have to mix, you'll just want a simple 1 component that can be taken straight out of the tin and applied with a brush. But then this compromises in terms of performance. So I think the last one in terms of the specification and consideration is how do you actually validate your coating performance? So if you look at a coating specification or a manufacturer's guidance to say the coating will last 20 years, and that's great, but what does that actually mean? And it's something to be quite cautious of, and it's something that we've seen quite a lot. So a coating lasting 20 years can mean different things, and that can be an aesthetic consideration, it can be corrosion, or it can be how much the coating remains intact. So what you'll actually find is that there's an allowance for aesthetic deterioration. So gloss and color will change over those 20 years. And what you'll actually find is that it's protecting from corrosion, but it won't look as pretty. The coating should normally remain intact, but it's also interesting to know what the maintenance requirements are, because the 20 years will normally be assuming that you're doing minor maintenance. So if there's damage, then you would need to go out and repair it. Otherwise the coating wouldn't perform as expected. And then it's worth knowing how that's actually been tested and how it's actually been qualified. So there's a few different ways that people do this, and they are quite different. And I could probably spend an entire hour talking about these. But the 3 different ways that you would generally cover this is in accelerated testing, which is a form of lab testing, and then real world track record. So accelerated testing uses techniques and cycles that try and simulate a 25-year or a 20-year offshore environment in as little as 6 months. So I've got quite a common one down at the bottom there. If you're a paint chemist, it's ISO 12944 Part 9. And it runs through cycles of high intensity UV and then condensation. And then it puts it in neutral salt spray, and then it freezes it. And it runs this cycle over 7 days, and it runs for 6 months. And then there are various criteria at the end that you assess and to understand the performance of the paint. And on the right, it's just one of the bits of kit that you would use. So that's the machine. So you'd put small panels in, and that would expose it to both the UV and the condensation, which in itself is a really harsh environment, but it isn't real life. It gives you an indication and it lets you compare products against each other. But if you see that as the result, it isn't going to guarantee that you'll get 20 years of real world experience. There is no damage in that, certainly, and all the other problems aren't there. So what then you want to look for is things like real world track record. So in the top photo up there is a panel rack. So most paint companies will have these, and when you start to work as a chemist developing products, you'll put your products on panel racks, send them off around the world to the different environments. And that gives you a reasonable indication of performance as quickly as possible. But again, these are nice small flat panels in quite tame environments on the whole, and it's not representative of a real structure. There's no welds, there's no corners. There is actually simulated damage on those. So the real one that you want to look for is real world track record, but that's difficult with new and innovative products. If you want 20 years of track record, what you need is a 20-year-old product. And again, that's difficult and most people wouldn't be able to provide that. So it's worth looking critically at the data. When you get told that this product's got a 20-year track record, find out if it's the same product, if it's not an older version with the same brand, the formulation hasn't changed. And actually, what information are you getting? I've seen quite a lot where the track record is a lovely glossy brochure of a boat or a ship or an asset being launched. What it isn't is a photo of it 20 years later. What does it actually look like now? I think that's quite a critical one. So when you do see something, think about it critically. And then, yeah, when you look at the track record, when you look at the testing data, also at that point it becomes quite difficult to understand what you're really looking at. And I'll come to that if I get a chance at the end in one of the case studies. So I appreciate that as a bit of a whistle-stop tour, but I'll try and talk through some of these examples in case studies. I am hopefully trying to keep to half an hour, so I may cut out one of these if I get run a bit short. But I've got 5 I'd like to talk about. So one is offshore components, which talks about some of the standards, a failure investigation, a specification, a technology review, and then a coating project on an iconic bridge. I've had to anonymize quite a few of these because I'm not sure if our client would actually like us to talk about them. So yeah, they're in generic terms, but these are specific things that we've worked on, often with sort of major multinational renewables companies, infrastructure companies and the like. So the offshore coatings components, our client won a contract to supply offshore. Their equipment that they were making was actually normally used in a quite a tame environment. So it was actually normally used internally onshore. And so the only coatings that they were applying were synthetics. They wanted it to be a nice color that matched the rest of the equipment. And then what they'd done is they'd won a coating job offshore and they'd been asked to apply a scheme that was suitable for NORSOC M501 Rev 6. And so they came to us to ask, how do we actually get there? What do we need to do? What does this mean? And what are the implications? And so what we did, we taught them through. So we gave them guiding on the standards. We actually did the site visit to set up their coating process to adapt it from being suitable for the aesthetic coatings through to actually being suitable for coating for an offshore environment. We helped them select coating schemes. We taught them through the quality and the documentation that they required and identified critical aspects and compromises. And it's a reasonably complex standard to actually understand. There's quite a lot of implications. I mean, they were particularly complicated because the component that they were using was made of mixed metals. So it was a mixture of galvanized components, cast iron and aluminium, which meant it was tricky to actually specify. So an off-the-shelf specification wasn't really going to work for them. But we did, we got them through, we got them approved, we got a coating scheme and their customer was happy. And so they were actually able to supply into the market. But what they had done before they contacted us is actually they'd tried to do it themselves and they'd had a few complaints and they'd had things fail in service. And these were going offshore and it was giving them a real headache because they were they were then having to retrieve these items to repair them. So this is just about getting things right first time, understanding what you're doing, understanding the limitations. The next one is a wind farm failure investigation. So this is quite a common thing for us to get involved in, because we're independent. People like us to come and give an independent opinion as to why something's failed, so they can work out, normally it's a blame as to who actually has to pay and who is responsible for sorting out the problem. So this was a premature failure in service. It's not actually related to the photo. That's just a nice photo of some foundations. They're actually quite good. And what we did is a review of the contract documentation, specification and guarantees. We did an inspection and forensic analysis. So we've got the option in-house to do optical microscopy, and then we can subcontract out things like SEM and X-ray diffraction detection, which looks at surfaces that are involved. And what we actually found from this, using our expertise, so using our knowledge of failures and using the analytical techniques, is that the system itself was poorly specified for the environment it was going into, which brings me back to the first comment, is getting it right first time. Poor surface preparation, even though I said it wasn't always the cause. In this case, it was the cause. And what we're able to do from that is you can actually identify who was responsible and who was most likely to end up with the cost of the repair. But these are things that we get involved in, and while it's good for us from a business point of view to be involved in failure investigations, from a personal point of view, I'd much rather be involved right back at the start, understanding the specifications and helping educate and inform people as to what the critical criteria are, what you really should be considering when it comes to coatings. We've got the inspectors to kind of give you that independent inspection when these jobs are being done. And then also, yeah, getting the specification right, understanding what's important. But we do learn from these and we feed back in to our clients. Next one is quite an interesting one, which is an offshore wind specification. So in this particular example, the company was applying or had offshore assets, and they were looking at specifying, and they brought us in to try and understand how they could actually make improvements. And to sort of really quickly summarize it, what we actually found is that they were applying an offshore specification to an onshore asset, and this was costing them a fortune. So they got the corrosion environment wrong. And in this case, from a performance point of view, they were going to be fine. They were going to get the lifetime that they wanted. But what they were paying for was a system that just was over-specified. I don't want to disparage the paint companies too much, but their main interest when it comes to paint is selling it to you. So if you say you want something that's really high spec, they'll say yes, and they'll sell you the most expensive product. And if it's over-specified, they'll definitely sell it you, because that actually is good for them in terms of making money. One of the things that we often see is that people request a particular thickness, which is somewhat bizarre because often it doesn't improve performance. But if you ask, can I apply twice as much paint? If they know it's not going to cause a problem, they'll say yes, because then they'll sell twice as much paint. What they won't say is, don't do that. It's going to have no benefit to performance whatsoever. It's just going to cost you more money. And so in that situation, is likely what's actually happened here is that they've had a specification and they've just grandfathered it and they've just used it in a new project when it didn't need to be used. And we actually potentially saved them up to 1.5 million euros by understanding what their environment was and giving them the right paint scheme. So they could actually tolerate a lower quality or a lower performance paint scheme because of the environment that they were working in. The next one is a technology review. So this is taking our ability from different industries to look at different coating systems that are used in different environments. So this was for an offshore wind operator, and they wanted to extend the assets lifetime in the splash zone. So the splash zone is, as it says, it's the area that's splashed by water, to put it very crudely, and it's quite an aggressive environment. So it's exposed to both UV, air, and also temporarily immersed through tides and wave action. And so it's probably the most challenging area of a structure to coat and to actually protect from corrosion. So what they wanted to do is they wanted to find something that was going to improve the lifetime. They were looking to actually extend the lifetime from 25 to 40 years. And they had some ideas as to how they wanted to do this, but they didn't really have the knowledge. So what we did is we helped them by talking them through the technology options and actually talking to customers and people who were already using this technology in other areas. So while renewables is relatively new, you can learn quite a lot from the marine and oil and gas industries, because these guys obviously had things offshore and in the ocean, in the marine environment for quite a long time now. And so they've got track record that goes back, and they've used all of these products. So you can understand the risks, you can understand the pitfalls, but only if you've got access to that information and understand those different markets. So we tried to help quantify what the realistic improvement was. So one of the things we could do is find track record, and this was real track record. So this was trying to talk to people who we'd had contact with and actually go and look at these structures and say, this is what it looks like after 40 years. We helped them understand the testing. So this went back to the accelerated testing and the in-house laboratory testing. What does it actually mean? So how do you take the marketing spin off that? And what does it mean as an asset owner when you see these graphs and these numbers? There were some challenges in application, in repair, and also in cost. So we helped them give a real appreciation of what that would actually mean. So the application did differ. It wasn't quite as bad as the picture that I showed previously, but it was a complicated piece of kit that needed to be applied. It was more difficult for the applicator, and they would need to be persuaded to use this technology and actually probably pay more to do it. And then we also gave them the actual products that were available. So taught them through the manufacturer offers and what the various comparisons were. So looking at the technical data available, tell them which products would be most likely be best for their end use. The final one is an iconic bridge. I can't tell you which one it is, and these photos are just for illustration if you don't think that bridge looks particularly iconic, which I don't. And I know this isn't actually the marine environment, but it was the bridge that we were working on was coastal, and there's quite a lot of interesting lessons that came out of this. So it was a multi-million-pound refurbishment, and what we did is we helped the owners, or the asset owners, develop a functional specification. So understand what the environment was and what the challenges were of what they were coating, and then produce a specification as to what the requirements were of the coating. We then did a technical review of the coatings bids. So after they put out the specification to the various paint companies, who then submitted their options, and what we did is review the options and say what we thought was going to be best and where information was lacking, and looked at the general quality. So there were quite a few unique challenges to this project. First was it was coastal, but being a bridge, it was also had access for pedestrians. So graffiti was a real challenge. So it wasn't just about the aesthetics as how it looked, it was actually how, when somebody comes along and spray paints a little bit and damages it, how do we actually repair that? Because it's going to happen. So it's like this damage situation. It's predicting that these things are going to happen and understanding what you're going to do before they happen. Birds were a massive challenge with it being coastal environment. So again, one of the things we asked all the coating manufacturers and the people producing the tenders to say was, how does your coating survive bird droppings? It's all very well saying that it survives the marine spray, salt spray, but will it survive? Yeah, will it survive the acidic nature of bird droppings that are going to nest on it? And we can't, they couldn't do anything about that. So they had to just accept it was going to happen. Then it was just a challenge, and they needed test data to ensure that that was not going to be a massive problem for them. And then we came to the more interesting one, which is actually understanding the results. And so they were quite interested in a 25-year lifetime, but it was an iconic bridge. So they were interested in corrosion, obviously, but they were actually interested in color fade and gloss, because this thing needed to look good for as long as possible. And what we actually did with them was we taught them through the test information that they got. We actually offered them, we promoted some of the novel coating solutions that are a bit more unusual, not something that they were familiar with at all, and recommended different coatings for different areas of the bridge. And because it was quite large, some of it's quite protected, so the undersides weren't in a particularly harsh environment and weren't exposed to UV. And so to get optimal corrosion performance there, you could actually use a different coating. Whereas the structure that was more visible to the public, we specified something that was better from an aesthetic point of view, because that was their primary interest. In terms of the understanding results, I think down in the bottom right, I've got a graph that says gloss retention. And that's one of the things that you will see when you see performance. And this is wonderful. So it's actually got 3 different products. One's an acrylic polysiloxane, one's a polyurethane, and one's an epoxy polysiloxane. And this graph is showing you gloss retention over hours. And it's basically saying that the acrylic polysiloxane is better because it doesn't lose as much gloss over time. But then that superficially is quite easy to understand, and you could see that. But then when you're a paint chemist and you've actually worked with these and you understand these and you work with them quite a lot, you start to question some of this. So the first thing that pops into your head is that this is accelerated, not real world. So you need to understand how that actually applies. So you've got 9,000 hours of exposure for the longest UV exposure there. That isn't very long at all. That's certainly not 25 years. What does gloss retention actually mean? So you've lost gloss from 100% down to maybe 60%. What does that actually mean as a client? How different is that going to look? Can you actually quantify that with some photos and help me understand? Again, that's something you can do using a historic track record. And the other one that always pops up is it doesn't mention what color was used. And as a chemist, that's a really important one. White generally performs better than other dark colors. So if it's a dark green, for example, in this photo, it may perform worse than that. And that may not be true across all colors. And so what you really need to do is ask for the performance for the color that you want to apply. So whites tend to go yellow, reds tend to fade, greens tend to fade. And so not everything behaves differently, and it's understanding that. So on the face of it, very simple graph shows one product is performing better than another, but in reality, is it relevant to what you're actually doing, and what does it really mean for real world performance? So thank you. I think that's my time up to talk, and I appreciate that is kind of a whistle stop tour of coatings, and I've rattled through it. So I'm quite happy to take questions, and I'm particularly interested in understanding if you're involved in coatings and the sort of challenges that you're seeing and what problems you're facing and where you think the most help would be required.
Thank you very much for that, John. I've definitely learned a fair bit there myself, including not to trust paint salesmen.
Well,
so,
I will. No, I think that's probably unfair, but their job it's understanding people's motives.
Yeah.
So they don't want to sell you a bad paint, but they want to sell paint, and they will sell you one of their paints, and they will try and sell you as much as possible as the most expensive paint. It may be good, but it may not be ideal for you.
Yeah. So I'd like to open the floor to any questions that anybody in the audience have. As John just kind of prompted there, he's quite interested to hear about some of your unique case studies, some of the challenges that you're facing. So by all means, raise your hand or put your question in the chat and we can come to you. I'm sure there's a few of you who have maybe got your own experience with this where things could have gone a little bit better, or if you're thinking about coatings for an upcoming project. Manuel, can I invite you to come on, to turn your camera on and ask your question to John?
Sure. I saw videos by CEMEC Atlantic and Orbiter Marine. So they were saying in order to protect the device and marine life, they use coating. And I think the Orbiter Marine video, they said they use 200 times coating. So has it for every title device to be customized, or is there, how do you evaluate how many times you should do the coating? 200 layers, which is pretty intense, but seems to be working. Thank you.
So what most people do right now would pick a generic specification. So I mentioned briefly the ISO 12944 standard. And what you'll find is that if you talk to a paint manufacturer, they'll have a system that is approved. So if you wanted to put something that was floating in the ocean, it'd be classified probably as a C5X environment. So it has a classification. And then from that, you'd be able to say, right, okay, so what coating schemes work in that environment? And then you'll find something. So there'll be a generic specification. So you'll take your environment, and then each coating will say, if you want to apply in that environment, use this coating scheme, and that'll be okay. And what it doesn't do, and whichever way I think when you want unique specifications, is it's quite a crude assessment of your environment that you're working in. I mean, it does work as an initial starting point, but it doesn't give you any of the uniqueness. So if there's something going on that you're not aware of, or it's particularly difficult, what you'll find is that you'll have problems. And that's so you will need in some regards to tune the generic specification, just to understand that it is going to work. So yes, you will need a unique specification for every project, but if you're in the same area, so perhaps if you're looking at foundations for wind turbines, it would be reasonable within a given wind farm to use the same coating system on every individual asset. I'm not quite sure about the 200 layers. If I had to guess without seeing what they were actually applying, I wonder if that was to do with anti-foulings and to stop marine organisms from growing. It's not, so this is the one area of coatings that I have never spent any time researching, but so I'll give you a high level overview. There are a couple of different ways of doing it. So the first is foul release, and that's almost like your non-stick saucepans that you would cook with. What actually happens is, because it's a non-stick surface, nothing can actually grow on it. So the barnacles never actually manage to land and establish themselves. It relies quite a lot on water movement to actually clean as well, so it can be limited. The other option is to do with biocidal antifoulings, and this contains chemicals within the coating itself which leach out and are toxic to the marine life that's around. So barnacles, effectively, they die. They can't, so it's things, I'm not sure if it's banned, but they used to use quite a lot of tin compounds and copper compounds. So these very slowly leach out into the layer around the coating and prevent things from living. And what you find with those, because you've got this chemical that needs to leach out, a ship, getting quite detailed now, a ship normally only has about 5 years between service. But if you've got something like the orbital device, I'm guessing that has to be out in service for maybe 25 years. And this becomes a real challenge because you then need to put on 5 times as much. So they probably did have to apply a huge amount of coating in that particular case. Because like I said, these are normally designed for 5-year service intervals, and you'd reapply the anti-fouling. But for 25 years, you'd have to do some calculations. I'd have to ask one of my colleagues, but you'd be looking at, maybe 5 times the amount of coating just to provide this leaching of the chemicals. And then that comes back to the kind of thing that we get involved in. There are other solutions there that could potentially work. And you need, consider the drawbacks, because that's going to be very, very expensive to put on that much coating. I hope that answers your question. I think I did at the end, yeah.
Did, thank you.
Does anybody else have any questions for John? Please feel free to come forward. TJ?
Yeah, Jay, I have a question. Hi, John. Thanks for that presentation. I suppose I'm interested in, like, where would Safinah Group come in on a project? You know, if there was something being built and that the steel was coming out, like when the steel comes out, I think it already has a kind of a bottom coat on it. It's already protected in some way. But where would, or what's the best time for someone like you, a paint chemist? I've never heard that job title before. Where would they come in?
The answer is not just to say, I mean, I commented about paint salesmen, but I'm also consultants trying to sell our services. As early as possible is the answer. So we may not need to give much advice in the very early stages, but the design, I think, it can be critical. So again, it's worth asking the question when you actually first start designing something as to how is it going to be protected from corrosion? So how are you going to coat it? And thinking about it, because what people often do is that they'll design something, they'll build it out of steel, and then they'll have it sat, and then right, we need to paint this now to stop it from being damaged or stop it from corroding. And that's probably not the best time, because you're really compromised then in terms of what you can do. So you might have bits that you can't actually access that are difficult to coat. You've got challenges that you can't meet. You've got welds all over the place when perhaps welding wasn't the best answer. You may have to correct defects. So we've got, within Safinah, we've got engineers, and certainly in the marine side, we bring them in to help with ship design, and they are naval architects. So help with the ship design and actually reduce the coatings challenges. And that's sort of our ideal, is to get in and integrate it. So coating isn't something that's done after it's designed and built. It's something that's done while it's designed and built. It needs to be integrated into the process. So as early as possible, but we can come in at any stage. It just makes life a lot harder if you come in and you've been told this is what you've got, how do we paint it? Because then the answer is, well, that's actually really quite difficult. So the small components that we work with was a massive challenge. They couldn't do anything about that, but the fact that it was half cast iron and half aluminium was an absolute nightmare from a coatings point of view, because it really narrowed down what you could use. To find something that would work on both substrates and protect both equally was, well, it limited you to a small handful of options, which were quite difficult to find, which is why one of the reasons they struggled so much.
And I mean, would you design your own paint specifications then? depending on the environment? Like say if it was North Sea or if it was Mediterranean Sea?
Yes, so you have to work with the paint company information, but they do a huge amount of testing on these. So yes, but we'd help with the specification. So challenge what was actually being put on or what was actually being presented by the paint companies, because they've got options within any given range. They've got hundreds of products, and you've got 3 coats. So you've normally got a primer, an intermediate, and a surface aesthetic finish. And so that gives you a huge number of options. But yeah, so the North Sea and the Med would be, depending on what was actually doing, would be quite different. So the Med's obviously got quite a decent amount of sunshine compared to up here in the north. So there you'd be looking at more UV exposure, more hot heat weather exposure. I don't know if the salinity is different. I'd need to look at that, but I'm guessing the water, the actual water itself is different. So
salinity is much higher in the Mediterranean, I believe.
Yeah. So yeah, and then again, you'd look at things like that, and then you understand. So they may just say that this coating is fine for marine environments. Well, then you'd ask the question of, have you tested it in the Med? Have you tested it in the North Sea? And you'll find out that maybe they have, maybe they haven't, and then you can start to make risk-based judgments on that.
Really good, thank you.
I'd be interested.
Sorry,
You got a question.
one last question while I have you. Speaking about new paint, is there any emerging technologies that can be used in paint to make it last longer or assist a ship going faster or be resistant to bird feces, acidic?
That's a big question. So in terms of new things that are ongoing right now, so they're all paint companies research. So there are lots of paint chemists. There's hundreds of us. There's laboratories full of people all over the world working on these things. Am I aware of any step changes in performance though? Is a difficult one. So the example I gave in terms of the splash zone and the company that was looking for a new technology to extend life, that was actually quite interesting because that was an old technology that had been abandoned almost, but it had been abandoned for reasons of application and the fact that no one really wanted a 40-year lifetime. But we were obviously being aware of it as a historic product. We actually went back and looked at it and said, well, now look, the end use has changed. And so now this is of interest to people. So it wasn't new as such, but it was different. So that's one potential example, because people are pushing for more and more life. Whereas in the past, they may not have been on certain assets. It's not particularly new technology, but one of the ones, the non-stick anti-fouling is one that really has been pushed in recent years. I'm struggling because I'm trying not to give you the marketing spiel of my old company. But what they said from this is, but by applying the non-stick anti-fouling, I'm trying to think of a non-branded way of describing it. But they effectively said that you saved a percentage of fuel costs, and I think it was in the region of 4 to 5% of fuel costs in ships. And that was just because of the drag you get from barnacles, slime, seaweed, and other things growing on the hull of ships. So yes, in that, yeah, I mean, that is new-ish technology and it is being developed all the time. But a lot of the changes are incremental. Right now, other innovative things, we did work as a company on a project to do with UV lights on the hulls of ships. And that was a way of stopping things from growing. So that was not the anti-fouling chemistry, not the non-stick chemistry, but using UV light. I mean, I don't know if you work in other industries, it's used for things like water purification, and it's the same principle again. And so by putting UV tiles on the hull of the ship, it was demonstrated that you could stop things from growing. So it was more environmentally friendly. It lasted for a long time. And it's one that I'm interested in for people who are working in renewables, who want anti-fouling for 25 years, but don't want to put on a lot of paint. Something like that might be the solution. And I'm not sure how commercial it got, but I've certainly seen, yeah, there's been quite a bit of work on it. And if anybody's interested, I can probably dig up the work that we did on that and talk to you about it.
UV tiles.
Yeah.
It's interesting. Did I hear somebody else trying to come in with a question then just before TJ's? Was there somebody else who was trying to ask one?
Yeah, I was going to ask, but I think TJ read my mind. It was about, scope for improvement in paints. Or are we there yet? But I think that answered it quite nicely, John.
Yeah, I mean, I think people are looking, I mean, at the minute, the general trends are longer lifetime for assets generally. So things are getting more expensive. Wind turbines are getting bigger, more expensive, and people are generally looking for around 25 years. But people are asking the question, what happens if we go for 40? If you take the example of the oil and gas industry, everything that was designed for 25 years in the North Sea, it's still there. It's still working. They're still trying to keep it going and get every last sort of dollar of their investment out of it. There's quite a big push for environmental performance. That was obviously something that I was working on quite a lot. A lot of the chemistries that people are using by their very nature are quite hazardous, harmful. So you look at things like epoxies, I think things, polyurethanes, they contain quite a lot of hazardous materials. So a lot of work's been going into actually reducing that. Again, it's renewable sources, not damaging the environment, less solvents. So there's quite a lot of motivation there to do something, particularly in the renewables industry, because a lot of their message is based on being better for the environment. And so trying to understand every aspect of their process.
Question in the chat from Manuel again, just asking about the use of robots in applications. Do you know anything about that, about sort of new ways of automating applications of coatings?
Yeah, so this is, if you're actually interested, if you drop me an email, I will try and dig up the article that one of our principal consultants wrote, because we do quite a lot of thought leadership and talking about the future of paint. And yeah, we are seeing a lot of robots, drones, so used in different areas. So there's quite a few. So one is for cleaning the hulls of vessels. You'll see robots that crawl under the hull and actually scour off the barnacles. Rather than trying to do it manually and actually having to bring the ship out of dry dock, you can actually just do it while it's static. You can use robot crawlers to do that. Surface preparation, again, is another one. So blasting, but you are limited to large flat surfaces on the hull. So robots that can actually blast or look like vacuum cleaners, again, that crawl, blast and clean up after themselves. Painting wise, yes, again, drones. I can't think of an example that isn't my old company, but if you Google drone paintings, you will come up with it. But yeah, it's being used, because one of the things that you'll find, if you look at paint application technology, it's brush, roller and airless spray. And that's been the same for longer than I've been in the business. There's nothing dramatically different happened there. Yeah, but they have their limitations. Like I say, it's large flat surfaces are where they end up. Although there are quite a lot of those in most designs, certainly the marine industry. But the more complex ones is difficult. And that's, it often ends up being, I mean, a stripe coating is not something you could do robotically very easily, because every environment's so different and actually getting the equipment in is so difficult.
Be a while before the technology's there yet then. So we're coming towards the end. I'm just going to throw out an opportunity for a final question. If anyone's got one, please throw your hand up. Otherwise, we will be closing the session. 3.
One quick question, maybe. Yeah, because I was thinking about the testing and sort of validation side of things you were talking about earlier, which was really interesting. How many products actually have 25-year sort of real world track record data? Is that, because presumably, like in 25 years time, we're going to have better paint, so those ones then become redundant anyway.
Yeah, I mean, that's fundamentally your biggest problem, is that you find a 25-year life cycle for a product for development and actually selling it is far too long. So you'll normally look to release a new iteration of a product in 5 years, say, and you'll actually want 25 years. But it does exist in some ways. It's done quite cleverly in that you can actually start getting some of your track record through experimentation before the product's sold. So that was always a big thing. There are differences there, obviously, if it's not on a real vessel in real working, but if you're putting out test panels or test apparatus, you can get a decent amount of track record. But it's understanding what you've actually got. So yeah, you're going to be limited, but what have you got? Is it 5, 10, 15, 25? And then trying to link that up with the accelerated testing as well.
Mm-hmm.
There are complications with iterations of products where people do try and build on previous brands. So you would say that it's based on the technology of a previous product, and therefore we can use some of that track record. And that's most of the time that is. I mean, normally that's sound in that it's believable, but it's one that you'd probably need to have a really detailed look at the formulation, or at least the technical data sheets, to understand. Because you find things like, again, you're not a chemist, but if you've epoxy is used as a generic term, but what they don't talk about very often in general paint chemistry is the other side of that. So it needs to react with something. So an epoxy on its own doesn't cure, it doesn't dry as a paint, so you need the other aspect. So if it's the same epoxy technology, is it the same curing agent? Are both components the same? They've changed something, so what has been changed, and would it be different to performance? And that can be quite a complicated thing to actually get involved in. But maybe then you can compare, I'm going on a bit now, but you could compare accelerated weathering tests of the two products and say, well, they perform the same on the accelerated test, so there's reason to believe that the track record would be the same. So it's making those judgment calls by having the understanding. And again, I'll sell our services. If you're a paint chemist and you've been working in this, obviously I've done these tests. I've spent 12 years formulating them, so understand these tests in detail and the limitations.
Cool. So we'll just go to Patrick now for our final question, and then we'll wrap up today's session.
Yeah, cheers, John. That was a very interesting presentation. I'll try to be quick. We're Orbis Ireland, we're a Riverine and Untitled product developer, and I'm just wondering if you had any experience with protection of composite materials in a seawater environment. You know, from cavitation or ingress into the matrix itself, which can cause damage to the overall structure.
Personally, very limited experience of coating composites. It would be I'd be interested if you actually have some more questions. I could look that up. I'd need to talk to some of my colleagues to see if they'd actually done anything. It's an interesting challenge. I mean, normally the matrix that your composite matrix is pretty similar to the types of coatings technology that you will be using anyway. So I don't know, epoxy is a common, again, epoxy amine is a common one, polyesters, depending on what you're actually using. So you wouldn't want the anti-corrosive side of it, but the barrier coatings could be of use. So you'd probably want to think about how you did that, but then the substrate itself would be different, and it would move and contract in different ways. So you really want to see some testing, because I'm guessing it flexes differently and it'll have different coefficients of thermal expansion.
Even surface preparation, I'm sure, would have to change as well, because I'm sure it's pretty abrasive in terms of steel versus. Yeah,
well, you might be. It depends on how you integrate it into your design, because the composites themselves depends how long it's sat around for before you coated it. Because if it's the same chemistries, then you could actually overcoat quite nicely, because you would have a chemical reaction potentially. But there are abrasion techniques for everything. In terms of blasting, you can blast with everything from sort of dry ice, sponge, through to chilled iron grit. So you can tune that to the surface. So you'd need to abrade it to get a key. And that wouldn't be too difficult, I say, not being a blaster. But there are definitely options that I could think of that would work there. And then you'd look at how you actually validated your performance. But I could see, barrier coatings would work. So things that don't actually have any chemical reaction to prevent corrosion, but just physically stop water and air meeting the substrate that you're trying to protect. It'd be an interesting one if you'd like to get in contact, though.
Yeah, definitely. Yeah, get your email or something. That'd be fantastic. Cheers.
Yeah, well, I put it up on the last slide, which I think will appear when I send out the presentation.
Great. Okay. Thank you, John. Cheers.
Yeah. So we're going to have to close today's session now. Thank you all for having your questions, and thank you for John for being with us today, for your presentation, and for answering those questions. Maybe if you could drop your contact details in the chat, just for people to grab it now if they do want to follow up with you or ask any more detailed questions. So it'll just be there for people to grab before we close. So yeah, as we mentioned at the beginning, this is part of a series of events. So if this is your first one, if this has grabbed your attention, or if you've been to others before, you can head over to the Selkie website. That's selkie-project.eu. Go onto the events tab, and we'll have some details there. Oh, it's just been dropped in by one of my colleagues. So in there, you can watch the recordings from all of the previous Meet the Expert sessions to gain more insight into, entering this new and exciting sphere of marine renewable energy, or you can sign up to attend some of our future events. thank you again to our speaker, to our expert. Thank you all for joining us. Nice to see some familiar faces. And I'm glad that these sessions are proving useful to some people. But yeah, enjoy the rest of your week and the rest of your day, everybody. Goodbye.
Yep, thanks everybody.
Thanks, Jay, John. Bye now.
Thank you. Bye.
Thanks,
so
John.
much.
Bye bye.
Cheers.